So just your basic formulas over here when we're working with area. With most of these are going to be two-dimensional objects. So when we're talking about the area, remember we had mentioned how when you're multiplying units, since you're going to be doing, unit times unit, you should get unit square. So area will be square inches, square feet, square meters, depending on what it is. When we get into volume, that's a three-dimensional figure. So you'll be multiplying the unit of measurement 3 times. So that's where you get, cubic feet, cubic inches, and those kind of things. So some of our basic shapes over here, you've got your triangles. So triangles are defined as area base times height. So when you are looking at base, particularly with triangles, what we do is wherever you're putting that vertical height, it should be making a 90-degree angle with your base. So the base is where basically the height of your triangle will be making a 90-degree angle at. So depending how your triangle is oriented, the base and height can always keep changing. And so we'll look at different examples for that. Of course, rectangles is going to be length times width. Parallelograms kind of work like triangles also. So in this case, when we did the perimeter, for the perimeter, we were looking at, length, width, and width. That was for the perimeter. But when you're talking about area, same kind of thing, wherever your vertical height makes a 90-degree angle, that's going to be the base. So again, it's going to be base times height, like your triangle is. For a trapezoid, it's a little bit different because for a trapezoid, you are taking that perpendicular height between the two bases. So that's going to be this distance here. Again, it's making a 90-degree angle. So that's going to be our base, our height. And then you actually also take the opposite base from that and use that as part of your trapezoid area calculation. And then, of course, in circles, you either need the radius or the diameter to calculate your circumference, but also your area. So all of these formulas are listed right over here. So with a triangle, trying to get this on the same screen so I can show all of them. So a triangle is actually going to be 1/2 base times height, and it's kind of a little bit different how this textbook does it. They're talking about area, and then they're putting a sub letter T over there, so they know it's the area of a triangle. This would be area of a rectangle, area of a parallelogram. So, they're putting those letters there, but honestly, you don't have to do it that way. If it's comfortable for you, go ahead and put the sub letters, T, R, P, whatever else there might be, or you don't have to. So anyway, our area of a triangle is going to be 1/2 base times height. So in this triangle, this would actually be your base, and then you would drop a perpendicular from the, the top of the triangle to where your base is. So then this becomes the base. This will become your height. For a rectangle, it's length times width. So of course, this guy is our length. This one can be your width. Parallelogram also is base times height, but you will see for a triangle, we did 1/2, whereas for a parallelogram, it's base times height. And the reasoning is I can actually drop a diagonal here in my parallelogram, and you will see it creates 2 triangles. So that's why the area of a triangle is basically 1/2 of the area of a parallelogram, because the idea is you can take 2 identical triangles, or honestly, they don't even have to be identical, but you can take 2 triangles and fix them together to create a parallelogram. And basically we can break it up into 2 parts and get 2 triangles out of it. So the area of a parallelogram is going to be base times height. So again, remember, drop a perpendicular from one side to the other. This becomes our height. And then where you're dropping it will become your base. So base times height for that. Trapezoid, as you can see, is going to be, again, that perpendicular distance between the 2 bases, which becomes our height. you can think of this as base 1, this as base 2. So you are taking 1/2, then you are adding base 1 plus base 2 together, and then you take 1/2 times that sum of the two bases times the height of your, the distance between the two sides, and that becomes your area. And then, as I already kind of talked about this before, area of a circle is pi r square, and r, of course, is the radius that goes from the center of the circle to the side of your circle. So that's going to be your radius. So it's going to be pi r square. So as you can see, when you are looking at the area of a circle, you don't really have an alternative form like we did with the circumference, right? Where they said you can use pi times d, or you can use 2 pi r to finding the circumference. In the area, you have to have a radius. So if they give you a diameter, remember the diameter is defined as 2 times the radius, or conversely, the radius is defined as diameter divided by 2. So you will need to find the radius to come up with the area of a circle. So these are going to be the main shapes that we are talking about. So this is what you kind of want to, either write it down, in your cheat sheet or whatever, but these formulas will definitely come in handy. So let's go ahead and look at some examples on calculating these area measurements. Let's actually do these examples here. Alrighty, so we're starting out with our triangle over here. So remember, area of a triangle is 1/2 base times height. So in this case, 1/2 of course stays the same. Your base is going to be 18 and your height is going to be 4. So that's going to be 18 times 4. And then remember, you are doing centimeter times centimeter. So that means you should come up with square centimeters or centimeters square as your unit for this area over here. So can you tell me what our answer comes out to be? Brooks, very nice. Okay, guys, let's see your answers over here. Sabrina, very good. Sarah, very nice. Okay, Michael, I'm not sure where you're getting 23 from. Amanda, good. Kendall, yeah, very nice. So you've got 1/2, which means you're dividing by 2. So now you can take 2 goes into 18 9 times, or you can do 2 goes into 4 2 times, doesn't matter. One of them will reduce down, and then you basically end up with 9 times 4, which we know will end up giving us 36. So you should get 36 square centimeters or centimeters squared as your answer over here. And you can verify that very quickly. Okay, wonderful. Let's look at our rectangle over here. So remember, rectangle is the area length times width. So of course, in this case, you are looking at length as 9.26, and you're multiplying that with 4.05. And again, you are doing millimeters times millimeters, which of course will end up giving us millimeter squared. What do you think this guy comes out to be? Okay, very nice. I'm seeing Sabrina, Amanda. Sabrina, you can just for the answers right now, you can just do SQ for the square and then put your unit of measurement. That should be fine. Michael, very good. So again, basically in this case, since they're not really telling us how they want us to round, and sometimes even in my open math, they don't really sometimes care about rounding. Sometimes there are instructions, sometimes they're not. So, when in doubt, keep all of your decimal. Brooks, that looks very good. So yeah, you're multiplying 9.26 times 4.05. So that should come out to be, as you guys have shared with me, 37.503. And of course, remember that's going to be squared millimeters for the unit of measurement. And again, you can verify that answer very quickly from here. Okay, let's look at some other shapes. So now we're getting into parallelogram and trapezoid. So remember, parallelogram is going to be base times height. So again, in this case, your base is going to be, where the perpendicular height meets at 90 degrees. So 2.6 becomes the height. 5.1 becomes the base. So what will this come out to be looking like? And again, I need everybody to share their answer just so that I know you guys are comfortable doing this math over here. So again, we're doing inches, so this should be squared inches. Okay, I'm seeing some answers coming through. All right, let me take a look. I've got Michael, Kendall, Amanda, Brooks, very nice. So yeah, Sabrina, right now we're not worrying about rounding. We're just leaving the answers as they're coming up, but rounded, your answer looks fine. So 5.1 times 2.6. Sarah, that answer seems larger than what it should be, almost double is what I'm looking at. So you're just doing base times height. So it's just 5.1 times 2.6. So I don't know if you ended up doubling that, like multiplying by 2. Yeah, okay. Alrighty, so guys, this should come out to be 13.26. Okay, that's what I thought. Alrighty, no worries. And you can again verify that from our solution. So these were actually, pretty straightforward. For the triangle, we did 1/2, but basically base times height. Rectangle, same thing, length times width. Parallelogram, base times height. Now for your trapezoid, remember this was a little bit different. So we did 1/2, but then you have to add our two bases together and then the height included in that. So honestly, it doesn't matter which one you call base 1 and which one you call base 2, as long as those are those two parallel sides to each other. And then the vertical perpendicular, of course, becomes your height, as you can see over here. And then we do the factor of 1/2. So let's see, we will be adding 17 with 32. And then, of course, we're multiplying the 1/2 and the height, which is 15. And this guy is going to be, so since you are adding B1 and B2, remember this will just be one dimension. So that's just miles from there. And then you are multiplying with the height, which is also miles. So you are only doing a two-dimensional, miles times miles. So you are still going to have only miles square as your answer. It's not going to become, to the third power. All right, so I've already got answers coming through. Now remember, addition has to be done first because it's combined together in parentheses. So add first, and then you will be multiplying. So just be careful about that. So we've got 1/2, then you're multiplying that with 17 plus 32, which of course will come out to be 49, and then you're multiplying that with the 15. So that's what your final result should be. Because I'm seeing a bunch of different answers over here. I've got, let's see, 367.5, and a bunch of you got that. And then I have 257 as the other answer. So either 367.5 or 257. So let's see what that guy is going to be. So we are going to do, I'm actually going to multiply 49 with 15 first. And then you can either divide by 2 or multiply by 0.5. So Michael, what do you think happened with the answer over there? Yeah, very nice, Brooks. Sarah, I see your answer in there. So Brooks, Sarah, Sabrina, Amanda. Because I'm trying to see how you got 257. Okay. Not entirely sure where the 257 is coming from. But yeah, it should be 367.5 for this one. And again, you know, if you wanted to verify, you can look at the solution here. So any questions on these 4 shapes that we've looked at so far? Okay, none so far. Now let's get into some circles. Looks like we're gonna have to.
What was the right answer for the last one?
That should be, hold on a second, 367.5.
Huh.
Because you are doing 1/2 times 49 times 15. Are you able to come up with that?
Yeah, I just did everything wrong.
Okay. All righty. So area of a circle, remember, is pi r square. So in this case, you know, for pi, actually, since they want the approximate answer, they're telling us here. So since they want the approximate answer, remember for pi, we use 3.14. And then you are using radius is given to us as 12. So that's going to be 12 squared. So technically, the way this works is, let's see how that unit comes out to be. So since you are doing 12, you know, r squared, you're basically taking 12 feet multiplied by 12 feet. So that's where you will see we're coming out with that feet times feet, you know, so that's where the square feet will come from. And then basically you are just multiplying the 3.14 with 12 times 12. So let's see what answers you guys are coming up with, okay? Sabrina, Brooks. All right, very nice, guys. Okay, let's see what the rest of you are coming up with. Kendall, very nice. Sarah, very good. Okay, Amanda, Michael, what did you guys have on that one? So remember, Amanda, you do need to multiply the pi value with that, right? So you need to actually do the 12 times 12, which is 144, and then multiply 3.14 into that. Now, if we were doing an exact answer, then yes, you wouldn't have to worry about the pi and leave it as 144 pi. So Sarah, you can access this document. Amanda, very good, yeah. One second. So if you go under the reading section of chapter 2, this is going to be the link that says area and volume on it. So it should be the third one down. Yeah, you're welcome. All right, very nice. So let's see our final answer. And those of you who shared your answer had the right one, was 452.16 square feet. And again, just a quick verification on that. So let's save this. I'm going to clear this out. Now this one, as you can see, is kind of getting into, multiple different shapes. So let's take a look at how we can break this guy down over here. So of course you can see they've already given us this little dotted line over here. So this guy is making a triangle. Now, what kind of shapes can we get out of this larger section up here? What can we break this down into? Yeah, Michael, very nice. We can get a semicircle out of it. And then Amanda, you said we can do a rectangle and half of a circle. Michael, rectangle. Yeah. So you literally want to take that dotted line basically, and let me see if I can try and get it to stay straight, or maybe see if this will work. And, just kind of extend that straight line. And you can see we can kind of create a rectangle and a semicircle out of this. So as you can see, they're telling us this distance over here is 5 centimeters. Of course, this guy is 7 centimeters. If we're making a rectangle out of, this shape over here, then basically we need to find the area of the rectangle over here. With the little triangular one, you can see this guy is going to be 2 centimeters here. But then, kind of want to keep some of my lines over here. So we need to actually figure out what this distance is going to be over here. And the only way you can figure out what this distance is to basically figure out what this distance over here is going to be. So let's talk about that distance from the circle. What do you think this distance should come out to be? Which basically becomes the diameter of your circle, right? Kendall, yeah, very nice. Yeah, Amanda, that's what it's going to come out to be. So you can see they're telling us the radius of the circle, Michael, very good, is 2 centimeters. So that means, if we think of that circle center, breaking this into halves, this would be 2 centimeter and 2 centimeter, which then of course gives us a total of 4 centimeters for the circle. And since you have 7 over here, this guy comes out to be 7 minus 4, which will give you 3 centimeters for the height of the triangle. So basically, the height of the triangle is going to be 3 centimeters. And I'm actually going to go ahead and erase this. This one over here is going to be 4 centimeters. And then we already calculated that this guy is 3. So let's get rid of that. So let's see, we need to find the area of the rectangle. We need to find area of the semicircle. We need to find area of the triangle. So the formula for area of rectangle is going to be length times width. The area of the triangle is going to be 1/2 base times height. Now, how do we modify the area for the semicircle? What would we need to do? Because the original is, pi r squared, but that's for the full circle. So what should we do? Yeah, take its half. Very nice. So you will end up dividing this by 2, or, you can kind of do that fraction of 1/2 like we have in the circle. It really doesn't matter. So please go ahead and tell me what the area of our rectangle is going to be. So just for this section over here, what is the area? Yeah, Amanda, very nice. Kendall, very good. And you're of course doing centimeter times centimeter, so this will come out to be square centimeters. So 7 times 5 will give us 35. Okay, Michael, let's verify that. So we got the rectangle taken care of. Let's do the circle. So this would be 3.14 again for the pi. The radius is going to be 2 centimeters, so that will be 2 times 2, so 2 squared, and of course again it's going to be squared value. So what does the area of the semicircle come out to be? And then of course you're dividing that by 2 to take its half. So area of the semicircle, what is that coming out to be? Amanda, yeah, very nice. So you are honestly, since you're dividing by 2, one of those 2 squared values on the top actually disappears. So you literally just end up multiplying 2 times 3.14, which will give us 6.28 for the semicircle. And then the last part, so this guy is done. The last part is going to be the triangle. Now, can you tell me which side becomes the base and which one is the height in our triangle over here? What do you treat as the base and the height? Because remember, the height has to make a 90-degree angle with the base. So what is your height? What is your base? Sabrina, very nice. Kendall, good. So again, the dotted line is the line that's making the 90-degree angle with our 2 centimeter side. So the 2 centimeter is going to be your base, and the 3 centimeter is going to be the height of your triangle. So our base is 2, our height is 3, and this will again be square centimeters. So what is just the triangle? What is this area coming out to be? Amanda, very nice. Okay, for the rest of you, what are you getting as the area of the triangle here, guys? And then when you add all 3 together, you should end up with the total area of the figure that we had. So what's happening in the area of the triangle? You're basically multiplying 2 times 3, but then you have the 1/2 in front of it. So for the triangle, actually those 2's, one is on the denominator, one's on the numerator. They can honestly cancel each other out, and you will just end up with 3. So yeah, Sarah, remember to multiply by that 1/2 or divide by 2 to get your area of the triangle. Okay, and then taking the 3 values together, which is going to be the 35, the 6.28, and then the 3 centimeters, putting it all together should give us our total area, and here you are adding these numbers so that square centimeter will stay as it is. And this will come out to be, and many of you have already shared this answer with me, is going to be the sum of 35 plus 6.28 plus 3. So basically 35 plus 9.28 will come out to be 44.28 square centimeters for this guy. And again, you can verify your answer from that solution. Yeah, very nice, Sabrina. Very good. And then Brooks, Amanda, and Michael, I believe you had also the same answer. Let me go back up. Yeah, very nice. So questions on this example over here, guys. So very similar to, what we were doing with the perimeter, where you had these multiple shapes being combined together and you kind of separate them out and find each individual area. And then, of course, we just put it all together, and that's exactly how we get our final answer over here. Okay, so let's clear this out. And now we're working our way into volume, which, remember, again, is going to be three-dimensional objects. So basically that would be, to the third power. So these would be cubic measurements, a square cubed, meter cubed, and that kind of thing. So in this case, when we are looking at something like, think about a box, that is what your rectangular solid would be like. So in this case, you are going to have three dimensions. So we have the length, we have the width, and then, this one here is what we call as the height. So those would be the three dimensions. A sphere, of course, you're thinking something like a ball. So that's still going to be working with radius, as you can see over here, but then, this is going to be three-dimensional. You can also have something like a cylinder. So, think about like a can of, beans or something like that. So in this case, a cylinder, of course, the ends are going to be circles, right, on the top and bottom. So again, we have to think about the radius for a shape like this, but then we also have to think about what is the height of the cylinder. So we'll be taking that into consideration. Now, this is what I was talking about. They are only talking about a cone here. So they are, literally, and this is a very bad rendition, but, this is a pyramid. So we do need to work with both cones and pyramids. With the circular base, again, we have to look at a radius, but then you look at a height. If you were looking at a pyramid, then, you would be looking at the area of the bottom, which could be length times width, or, if it's a square, it can be side times side, but then we would also be, looking at the height of the pyramid also. So we would have to take that into consideration. So your formulas for these shapes, you can see right over here, is going to be, for a rectangular solid, it's going to be length, width, and height. For a sphere, of course, it's going to be radius, but the formula comes out to be 4/3 pi r cubed. So that's going to be for our sphere. Cylinder, of course, again, you are looking at the radius of your circular, top and bottom, and then, of course, also the height. So this guy comes out to be pi r square, which, imagine, that is the area of a circle, and so you're taking the area, of course, of the, opposite top or bottom, and then you're multiplying that with the height to get your volume of a cylinder. So 3 dimensions. Cone, basically, again, since your bottom is going to be a circular, again, you are taking the area of the bottom, which is going to be pi r square. We take the height into consideration. And then basically what happens is, as you can see, we start out broader on the bottom, and as you go up, it starts tapering. So the idea is, as you go from the bottom of the cone to the top, it tapers by 1/3. So, that area is reducing by 1/3. And that's where that factor of 1/3 comes into play, which is kind of the same thing you're doing with that 4/3 on the sphere. So this becomes your perimeter, sorry, not perimeter, your volume for a cone. And then remember, for a pyramid, it would be 1/3. And then this could be length times width multiplied with height, or if you have a square on the bottom, this would become 1/3 side times side, or side square times the height. So that would be, the formula that I was showing you earlier. So this basically has to be 1/3 the area of the base times height. So whatever the base of your cone or pyramid is going to be. So we'll look at examples of a pyramid later on, since this current textbook actually doesn't have it. So again, we're just going to pick our examples from here and work them out. So they're telling us to find the volume of the geometric shape. We are finding approximate volumes, and we're keeping our pi value at 3.14. So let's see how we can work through these examples here. So this would be volume of a rectangular solid. So like I said, think about a box. So this is length times width times height. Our length is going to be 9 inches, width is 10 inches, and of course the height is 3 inches. So can you tell me what this comes out to be? And you are doing inches times inches times inches. So of course, cubic inch. And you guys can write, CU for the cubic. So cubic inches would look something like that. So what will this answer come out to be? Okay, I've got Michael and Amanda here. Okay, what about the rest of you? What do you guys got? And multiplication by 10 is easy. Honestly, just multiply 9 times 3. And then multiplying by 10 basically means you slap a 0 at the end. Sabrina, very good. Brooks, very nice. Sarah, very good. Kendall, yeah, perfect. So 9 times 3 is 27. 27 times 10 will give you 270, and that would be cubic inches. Perfect, guys. Wonderful. So that is our rectangular solid. Now for the sphere, we had 4/3, and this one I do want to confirm. Oh, pi r cubed, yeah. Alrighty. So 4/3 pi r cubed, which of course will come out to be 4/3. Remember, for pi, we are using 3.14. And then for r, of course, they're giving us the radius as 6 centimeters. So since you are doing to the 3rd power, you're basically saying, okay, so it's going to be centimeters, 6 centimeters times 6 centimeters times 6 centimeters. So multiply 4/3 with 3.14, and then 6 to the 3rd power. And this will obviously end up giving us centimeter cubed. Or cubic centimeters, which is also known as cc's, if you're dealing with medicines, right? A lot of times they talk about, oh, we're going to administer, 3 cc's of unit, which comes out to be 3 milliliters. So what are we looking at as the volume of this sphere here? Think a ball.
How are we doing 4.3 as a decimal? Because it could go on.
Say that again, Michael.
How are we doing 4.3 as a decimal? Because that's 1 1/3.
I would actually just multiply, 4 times 3.14 times 6 to the third power, and then divide the whole thing by 3.
Got it.
You
Okay.
don't want to round the 4 over 3.
Okay.
Yeah. So yeah, you guys can kind of think of, the entire thing is being divided by 3. So do the multiplication first and then divide it by 3, and that would be fine also. Okay, Sarah, I see your answer. Amanda, I see yours. Okay, Sabrina, now you did have a different answer from your classmates, so let me check. I haven't multiplied this. So 4/3 being multiplied with 3.14 and then multiplied with 6 to the third power. Oh, okay, Sabrina, okay. And of course, you guys can do 6 times 6 times 6 first, so go ahead and get that cubed done. But you should have either a place to put your exponent on your calculator, so you should be able to do 6 raised to the third power, but if you're not, you can definitely do 6 multiplied into itself 3 times. All right, Kendall, I see your answer. Very nice. So let's see, I've got Sarah, Amanda, Kendall, Michael, that looks good. Very nice, Sabrina. Yeah, perfect. That looks good. And this will still be cubic centimeters, but then this guy will finally come out to be 904.32 cubic centimeters. So again, we should be able to verify. Okay, this answer is incorrect, because they're all in inches. Interesting. I didn't realize they had a wrong answer key in there. Let's see, for the sphere, definitely 904.32. Okay, let's clear this out. So we've done the rectangular solid, the sphere. Now we're getting into the cylinder and the cone. So let's take a look at this guy here. So a cylinder was, sorry, I don't think it had a fraction in front of it. Pi r square h, yeah, so just the area of the bottom and then the height. Okay, so cylinder, pi r square h. So of course, the height of the cylinder is going to be 2 meters. And then you can see on the top, they're giving us the radius for the circular top and bottom, and that is going to come out to be 5 meters. So you are taking pi, which will again be 3.14. We are taking radius square, which means we are doing 5 meters times 5 meters. And then, of course, we are multiplying the height, which is also 2 meters. So you can see you're doing meters times meters times meters. That's where our cubic meters will come from. And then you're just multiplying 3.14 times 5 times 5 times 2. And I've already got answers coming through. Very nice. So basically 5 times 5 is going to be 25. You are doing 25 times 2, which is 50. And then 50 times 3.14 should be slightly larger than 150. So I've got Brooks, Michael, Kendall looks good. Okay, let's see what the rest of you come up with. So, when we talk about volume, you're basically thinking capacity, like how much, liquid or how much air or how much quantity of whatever can I put inside this, object that I have. So basically, with a can, something like a cylinder, we can say, okay, how much liquid is it going to hold? And that's kind of what you are calculating. So like I said, this answer should come out to be slightly larger than 150. Sabrina, that's way too high. What numbers did you multiply there? Did you do 5 times 5 times 2 times 3.14? Sarah, very good. Yeah, that's right. So it should only be 157. So yeah, check your math again, see what happened. But 157 cubic meters is what our answer should be. Oh, okay. I see. Okay. And again, if the answer key is right, then we should have 157. Okay, wonderful, Sabrina. 157 looks good. And then we have our volume for a cone, which will be 1/3. And since you have a circular base over here, you are going to have pi r squared, because you take the area of the bottom and then multiply by the height of the shape, the pyramid or the cone. So this will be 1/3. Pi, of course, will be 3.14. Your radius is going to be the radius of the base. So that's, of course, going to be, and I don't know if you guys can see, but these are decimal numbers. So they are giving us 0.1 inches for the radius. So radius squared would be multiplying that same number into itself. And then the height is given to us as 0.9 inches. So you will see we're again doing inches times inches times inches, which of course will then end up giving us cubic inch. And then you are multiplying, and I would do the same thing. So 1 times 3.14 will just be 3.14. So just multiply 3.14 with 0.1, multiply again with 0.1, and then multiply with 0.9. 0.9. And then at the end, just divide by 3 to get your final answer. So you can treat that 3 as, everything being divided by 3. So just do 3.14 times the radius square. So 0.1 times 0.1, and then 0.9 for the height. And then once you get that answer, divide by 3. And that will give you your volume for this cone. Okay, so Michael, I've already got your answer. Sabrina, yours looks good too. Kendall, very nice. And we will keep all the decimals here, guys, and you will see why, because this is, you're multiplying 0.1, 0.1, 0.9, and then divide by 3. So you're going to get a fairly small number here since you're dealing with decimals. Sarah, that looks good. It does, because you are actually dividing by 3. So dividing by 3 is what's reducing those numbers down. If you didn't have that 1/3, this answer would have been a little bit larger than what we have right now. So yeah, it's that division which is making it smaller. And then remember how decimals work. When we multiply 0.1 with 0.1, of course, it's 1 times 1, which gives you 1. But now we have 2 decimal places to take care of. So that becomes, 2 decimal places going backwards. So this answer actually comes out to be 0.1, because, think about 0.1 is basically 1/10 being multiplied by 1/10, which of course comes out to be 1/100. So even just working with decimals, your product does become smaller, because you're multiplying smaller numbers, which means you end up making your denominators larger than your numerators. Okay, so I've got Michael, Sabrina, Kendall, Sarah, your answers look good. What about Brooks? Amanda, what did you guys end up with? Didn't get an answer, is that what happened? Okay, Amanda, very good. So yeah, this will come out to be 0.00942, a really small answer comparatively. So let's take a look over here and you can see with our answer key, that looks good. Alrighty, so these will be your shapes that are given to us in this section over here. And this is talking about area. Sphere, trying to find a shape that I kind of like. I think these guys are pretty straightforward. Let's do one of these here. Yeah, why not? Let's do this guy. And they're asking us to find the approximate area in this case. So we had done something similar, but we had done the perimeter of that shape. This one here, we're talking about approximate area. So what are you going to break it down into? What are our two shapes going to be for this guy? Brooks, yeah, very nice. A semicircle and a triangle. And you can see they've given us the dotted lines in there, which will definitely make this a lot easier. So we're going to find the area of the semicircle first, and we're going to combine that with the area of our triangle over here. So let's start with area of semicircle, and then we'll find area of the triangle. So again, remember, area of a circle is pi r squared, but since this is a semicircle, divide that by 2. Area of a triangle, of course, is 1/2 base times height. So what are each of these areas going to come out to be? So remember, you need your base and height for the triangle, and then you're going to need a radius, which they are not directly giving you the radius, but you can figure out what your radius is going to be. So let's work on the semicircle example first. What's the radius for this semicircle over here? Amanda, very nice. Yeah, you take the diameter and take its half. So we know the diameter is 18 centimeters. So you take 18 divide by 2, which will give you 9 centimeters as the radius of the circle. And, you can kind of imagine it's going from the center to, the edge of the circle. Okay, Michael, let's verify that. So we will have pi as 3.14. The radius is 9. So this is going to be 9 times 9, or you can, of course, write it as 9 squared. Then you divide the total answer by 2, and this will be in square centimeters. For the triangle, guys, what is our base measurement and what is the height? Okay, Amanda, I see your answer. All right, Kendall, very good. Brooks. Okay, so, okay, Amanda, I see yours. So for the area of the semicircle, Amanda, you had 127.17. And again, we're not rounding our decimals, guys. We're just keeping it as it is. Very nice. So for the triangle, the height is going to be 26 centimeters. And of course, the base is going to be 18 centimeters. So this will be 1/2 multiplied by 18 multiplied by 26. And again, you can do 18 times 26 first, divide by 2, or however you want to break this down. 2 goes into 18 9 times. You can do it that way. Whatever works for you. What is the area of our triangle going to come out to be? And this will also be in square centimeters. Yeah, very nice, Sabrina, Kendall, those answers are perfect. So you will have 234 for the triangle. And then of course, for the area of the figure, just again, put it all together. So semicircle and triangle, we take those two areas, add them together. And Michael, you had already shared that answer with us. Sabrina, very nice. Amanda, very nice. Yeah. So 361.17 square centimeters. Kendall, very nice. Okay, and then let's just, okay, looks like they didn't share the answer with us on this, but that's okay, because we know this answer is correct. Anybody have questions on this example here, guys? Oh, what did I do? Did something. Okay. Trying to see. Do they have something on volume that we haven't done? You know what, actually, let me pick a quick example for volume on a pyramid, actually, just so that we can get a practice for it. Okay. Okay, let's do one of these over here. So you can see in number 9, you have a square as a bottom, and we know it's a square because both sides here have the same measurement, right? So we know this is going to be a square. So when you're calculating the volume for a shape like this, again, it's going to be 1/3. And remember, it's area of the base times height, which in this case will become 1/3. Since my bottom is a square, it's going to be side times side, and then multiplied by the height of the pyramid. So 1/3, this will be 4 squared, and our height is going to be also 4 inches. So you can see my side is 4 and my height is 4. So what will this volume come out to be for this pyramid here? Yeah, and this is actually going to have a repeating decimal, because you know 4 times 4 times 4 basically gives us 64, and when you divide 64 by 3, it's going to give you a repeating decimal, because 1/3 is basically 0.33333 repeating, right? So this guy comes out to be, and you guys have shared answers with me. So I've got Amanda, Michael, Kendall. Yeah, very nice. it will come out to be 20.21.333 repeating. And for now, we'll just round it to 2 decimal places. And this should be cubic units. They just didn't tell us what the unit of measurement is going to be, if it's meters, feet, inches, so they've kind of left it open for us here. Yeah, very nice, Sabrina. Perfect. So that was with a square bottom. Now, if we had a rectangle, it would look, something like this that you're seeing in number 11. Yeah, Amanda, very nice. So at this point, guys, we have done our discussion on area and cube. So what I want to do next time is practice with what if now we wanted to find, the cost of finding something. So, what if I was filling this up with, I don't know, balls, with beads, with water. So what would be the cost of, painting a different kind of shape? So that would be area. What if we were putting a fence somewhere? That would be perimeter. Like I said, what if we had a box and we were filling it up with some kind of product? What would be the cost of doing that? So that's what we're going to be working on Friday. And then that should be the end of this geometry part of cost estimation that we need to be working on. And then we will be moving on to the next part of financial math, which will be our simple interest, compound interest, savings, loans, and those types of examples. So this one is actually going to be a little bit different in terms of how you calculate, Sabrina. So this guy would be finding the area of the base here, which would be a triangle. So for the triangle, we would have to do the area of the triangle, and then you would multiply that with height. Yeah, exactly. So this one is kind of like a cylinder, but instead of a circular base, you have a triangular base. So that's kind of what this guy would end up looking like. But yeah, like I said, so we'll pick some examples next time where we're also going to bring in the calculation of cost as part of our discussion. So let me know if you guys have any questions. So obviously you have your 2 homework assignments available in My Open Math. I'll open one more homework section, and that will be just on volume. So that way you guys can practice volume with all of these different shapes. And then let me know if you need any additional help. One final reminder, guys, you are turning in your homework assignment from D2L, which is going to be on your application of percentages. So please remember that is due Friday at midnight. If you haven't already turned it in and you have any questions, you should be able to ask me between now and Friday, okay? All right, folks, have a wonderful morning, I guess afternoon, and I'll see you on Friday. So be careful, everyone. Take care. Bye, guys. Thank you. Bye-bye.
Hello.
Hey, Sabrina.